Hey guys, so hopefully by now you've seen the factor theorem. We're looking at another theorem here called the remainder theorem. Now, the remainder theorem and the factor theorem are incredibly similar. In fact, you do exactly the same thing for both of them. The only difference is, when we're dealing with the factor theorem, f of a is equal to 0. When we're dealing with the remainder theorem, we're not dealing with factors, so when we substitute in x equals a, we get a remainder. So, our theorem is that when you divide a polynomial f of x by x minus a, the remainder is f of a. So the value of the function that we get when we substitute in x equals a. So let's have a look at some examples. Okay then, first up we'll have a look at finding remainders when we divide expressions by other expressions. So we want to find the remainder when x squared plus 5x plus 2 is divided by x minus 1. So we are dividing this expression by x minus 1. The remainder then is given by f of 1, like that. So f of 1 is 1 squared, so 1 plus 5 times 1, which is 5, plus 2. So we got 1 plus 5 plus 2, which is 8. So the remainder is 8. Good times. Second example, we want to find the remainder when x cubed minus 5x squared plus 7x minus 1 is divided by x plus 2. So we're dividing by x plus 2. The remainder then is going to be f of minus 2. So we're going to get minus 2 cubed. Again, be very careful with the negatives and powers. Minus 5 lots of minus 2 squared, add 7 lots of minus 2, and then minus 1 on the end. So let's evaluate that. Minus 2 cubed is minus 8. Now minus 2 squared is positive 4. Minus 5 times 4 is going to give us minus 20. 7 lots of minus 2 is minus 14. And then we got minus 1 on the end. So minus 8 minus 20 is minus 28. Minus 14 is minus 42. Minus another 1 gives us minus 43 as our remainder. Okay, third example, we want the remainder when x cubed minus 3x squared minus 6x plus 8 is divided by 2x minus 1. So, we've got a slightly different expression that we're dividing by here, 2x minus 1. So remember, to work out what value of x we would want to substitute in, we set what is inside the bracket equal to 0. So 2x minus 1 is equal to 0. We then solve that. So if we add a 1, we get 2x is 1. Divide by 2, we can get x equals 1/2. So the remainder is f of 1/2. So we are going to have 1/2 cubed minus 3 lots of 1/2 squared minus 6 lots of a half, and then plus 8 on the end. So that's just the game of sorting out our fractions. 1/2 cubed is 1/8. Then we got minus 3 lots of 1/2 squared. 1/2 squared is 1/4. So we've got minus 3 quarters. Minus 6 times a half is minus 3. And then we've got plus 8 on the end. So we've got 1/8. Now 3/4 as 8 is 6/8. So we got 1/8 minus 6/8. Then we got minus 3 plus 8. So that's going to leave us with plus 5 like that. 1/8 minus 6/8 is minus 5/8. Now 5 in terms of 8 is 48. So then finally minus 5/8 and 48 gives us the remainder is 35/8. Jobs are given. Okay then, hopefully nothing too tricky up to here. All we're really doing is substituting values into a polynomial. It can get slightly trickier with this type of question when we are told the remainder, but one of the coefficients in the polynomial remains a mystery. So, here, when x cubed plus cx squared plus 17x minus 10 is divided by x plus 3, the remainder is minus 16. And we want to find the value of c. How do we do that? Well, if we're dividing by x plus 3, then we know the remainder would be f of minus 3. Now we're being told what the remainder is. It's minus 16. So what we actually know is f of minus 3 is minus 16. So what we're going to do is substitute in x equals minus 3. So minus 3 cubed plus cx squared, plus c times minus 3 squared plus 17 lots of minus 3 and then minus 10 on the end. We know all of that is equal to minus 16. So we now need to sharpen that up and solve for c. So minus 3 cubed is minus 27. Then we got minus 3 squared times c. Now minus 3 squared is 9. So we got plus 9c. Then we got 17 lots of minus 3. Minus 3 times 17 is minus 51. Then we got the minus 10 on the end. Now we know all of that is equal to minus 16. Okay, so we can now sharpen up the left hand side. So we got 9c. Now, minus 27 minus 51 is minus 78. Then we got minus 10, so that's minus 88. So we got 9c minus 88 is equal to minus 16. Now if we add 88, we get 9c is equal to positive 72. And then finally divide by 9, c is equal to 8. There's our coefficient, c. Jobs are good. Okay, final example for this video. So, quite a big one, very wordy one, very problem solving. So, f of x is x to the power of 4 plus 5x cubed plus ax plus 156. The remainder, when f of x is divided by x minus 2, is equal to the remainder when f of x is divided by x plus 1. So, we want to find here the value of a. So, what is this massive wordy question telling us? The remainder when f of x is divided by x minus 2 is the same as the remainder when divided by x plus 1. In terms of the function then, that's telling us f of positive 2 is equal to f of minus 1. So that's how our remainders come about. So we simply need to find f of 2 and f of minus 1, set them equal to each other and find a. So let's find f of 2 first. So f of 2 is 2 to the power of 4 plus 5 5 lots of 2 cubed plus a times x, so plus 2a, and then plus 156. So if we sharpen that up, 2 to the power of 4 is 16. 2 cubed is 8, so 5 times 8 is 40. Then we got 2a plus 156. So 16 add 40 is 56. 56 add 156 is going to be 212. So we've got 2a plus 212 is f of 2. Now we need to find f of 1. Sorry, f of minus 1. So f of minus 1 is minus 1 to the power of 4. And then 5 lots of minus 1 cubed. Like that. And then add, well, minus 1a. So minus 8 add 156. Now if we sharpen this up, minus 1 to the power of 4 is positive 1. Minus 1 cubed is minus 1. 5 times that is minus 5. Minus 8 plus 156. Now 1 minus 5 is minus 4. And then add 156. We've got 152 minus a, like that. So we got both of our remainders here. Now remember we were told the remainders are equal. So we can set 2a, so 2a 212 is equal to 152 minus a. So remember what we're doing there, the question told us the remainders are equal. We found the remainders, we are now setting them equal. So we now have an equation, fully in terms of a, that we can solve. So if we first of all add a to both sides, we get 3a add 212 is equal to 152. If we then take away 212, 3a is equal to minus 60. And then finally divide by 3a equals minus 20. Okay, good times. Hope you found this useful, guys. Take care.